So this unit is not testing your ability to do math. It's testing your ability to interpret data, which is important. It's like testing your logical thinking skills. It's pretty straightforward for the most part. What's hard about statistics is because you're interpreting it, it's open to interpretation. You know what I mean? So as long as your interpretation makes sense, then it will be a correct answer. So you'll see what I mean. There are exact answers in a way, but the interpretation just kind of depends. Okay, so 8-1 will be measures of central tendency. So guys, we're going to be looking at data sets, and we're going to be interpreting the data set. The first thing, that's what statistics is. Statistics is the study, analysis, and interpretation of data. So it says one way to analyze data is by finding measures of central tendency. So what we're doing is on 8-1, we're focusing on the center of our data. Now there are different centers of our data technically. So there are many different centers. So guys, mean is an average. Now think about it. If I have a data set and I find the average, won't that be towards the middle, roughly? Not exactly in the middle, guys. Think about it. What does average mean? Yeah, you add up all the numbers and divide by the total number. Do you guys see what I'm saying? It's a center. It's going to be towards the center. That's one measure of central tendency. Now, there are other measures of central tendency, so mean is one of them, average is one of them. Median is the actual physical middle of a data set, and mode is what happens most frequently, the most frequently occurring. So let's just look at some examples real quick. You don't need to be taking notes because it's all really straightforward. You know how to do it, just watch. So look at the data set here, 1, 2, 3, 3, 4, 5, 5, 9. If I said to you find the mean, find the average, what you would do is add up all the numbers and divide by the total numbers you added up. So right here, we added them up, divided by 8, because there was 8 total numbers, and it equals 4. Do you guys see how 4 is towards the middle? It's not right in the middle, but it's towards the middle. It's a measure of central tendency. So you would say on average, whatever this is, like what if this was years of experience at a job? So you would say this company on average has, people at this job on average have 4 years of experience, if that makes sense. Now median means actual physical middle, like the physical middle. So you literally just count in. So notice I've counted in 1, 2, 3. I've counted in 1, 2, 3 from below. And then the problem is now we're up 1, up 1. Do you guys see how we can't get an exact middle here? So we've got to calculate the middle since it's like evenly split here. So you would find the average. So we did 3 plus 4 divided by 2, which is 3.5. 3.5 would be our middle. Mode is what happens most frequently. Mode most. So 3 happened twice and 5 happened twice. So you could say most of the time, people at this job have 3 years worth of experience or 5. Does that kind of make sense? Most often. Most often. Okay. Now, one fun fact for you. If you have more than 2 modes, this is considered bimodal, that's okay. But if you have more than 2 modes, mathematically speaking, statistically speaking, you don't have any modes because it's all affecting your data the same. You have so many modes, it's like having no mode. Okay. Now, fun fact for you, we can do all this by hand, but our calculators also can do these things for us. Not mode. Mode is what happens most. You look with your eyeballs. But it can find mean and median for us, and I'm going to show you that in just a second. So just keep with me for a second. Now, an outlier is a value that is substantially different from the rest of the data set. So it's going to be an extrema, an extreme. It's extremely larger or smaller than the rest of the data. This would be an outlier. Now, think about this, you guys. An outlier can really skew your measures of central tendency, couldn't it? Think about it. If you have some huge value, isn't that going to pull the middle towards that value? Which might not be good. As a statistician, you've got to take that into consideration. So for example, let's look at this as an example of that. Obviously, if these are scores of students on a SAGE score, let's say this teacher only had 4 students for easy calculations. So if I said to you, okay, what's the outlier in this group? You would say 20, correct? This person got a 20%. That is significantly smaller than the rest of the scores. Now let's say that this principal's cracking down and tells the teachers, if your students do not get an average of 80% on their SAGE scores, then you lose your job. So this teacher, let's find our average, if you don't mind. Quickly find the average for me. 75 plus 90 plus 99 plus 20 divided by 4. So with 71%. So this teacher is then, like, let's say the principal is not a statistician. They just added up the numbers, crunched them, and went with it, and sends this teacher a letter of, you've got to resign. So then hopefully this teacher would then say, we better look at the context of my data here. So they would look and say, oh, but Johnny got a 20%, and he's only been at school 10 times this year. then if they were to take this to court, do you think they're going to win? This student, yes, definitely. If they take it to court and say, this student only came 10 times this year, does this 20% have anything to do with me as a teacher? No, and it's an outlier. That's the only student that scored that low. The rest of my students scored these better scores. So let's find a true average. So as a person at court, I'm trying to convince the judge, should I get my job back? What's the true average? 88%. That's pretty dang good. So this teacher would then, I guarantee, would win in court, in a court of law. Okay, cool. Now, we're not statisticians. We don't have the liberty of deciding to throw out an outlier. Does that make sense? But it helps put it into context for you. Because let's say that you guys, if you like statistics and you decide to go into statistics, you can make big bucks. Because these big companies like Vivint, Marriott, all these different companies, they will hire statisticians to come in and crunch numbers for them. And it's not hard. It's all calculator stuff. It's just being able to interpret the data and take it to the CEO and say, okay, on average, your company's doing this. On average, your employees do this. And besides average, obviously. So you'll see that there's more to it. All right, so now let's talk about the range of a data set, everybody. Range is the highest value, subtract the lowest value. Range is talking about spread of a data, what we're ranging over. So right here I have a data set, 2, 3, 5, 8, 10, and 12. If I said to you, what are these numbers ranging over, or what's the range, how many units are we ranging over? 12 minus 2. So the range, there's a range of 10 units. Does everybody see? We're spread out over 10 units. Now, question for you. Is that a good description of this data set? Maybe. I don't see any outliers, so that might be a good description. Pretty good? Now, here's one thing we have to take into consideration, though. If I gave you this data set and asked you to find the median, could you do it? Median means middle. So let's go find the middle. In 1, 2, 3. In 1, 2, 3. Uh-oh, isn't it between? So 5 plus 8 divided by 2. 6.5 is your median. Does everybody see? Now look what that did. That split our data set into a lower quadrant and an upper quadrant. Here is the upper half of the data set, and here's the lower half of the data set. Now if I asked you to find the median of the lower half, what would you say the answer is? 3. So right here is the median of the lower half. That's what we call quartile 1. Now let's find the median of the upper half of the data set. The middle, 10. That's what we call quartile 3. So then your actual median, the middle median, the actual median is quartile 2. So just, it goes in order. Median of the lower half of the data set is quartile 1. The actual median is quartile 2. And the median of the upper half is quartile 3. Now, if I asked you to find, instead of range, the interquartile range, a lot of times they'll go IQR. That means interquartile range. What you're going to do is, instead of taking the 12 minus 2, you're going to take Q3 minus Q1. So that would be a spread of 7. 10 minus 3 is 7. Can anyone think of, maybe as a statistician, why you might, in a certain data set, not this one necessarily, why you might choose to describe to Vivint an interquartile range versus a range? Yeah, so it doesn't include your outliers. Do you guys see why that would be important? If you go and say, well, that you're, let's say that someone at Vivint is making, one person at Vivint's making 300 million, and then someone's making 100,000 in a year, and you say it's ranging, your company pays a range of this. Well, what if that one person is such an outlier that really that's not a good description? Does that make sense? So you could say, well, this is technically, but if we're really looking at the majority here, really you're more ranging over this. Does that kind of make sense, everybody? So interquartile range. All right, now another way to look at this data set, if I was to ask you to put this into a box and whisker plot, it's this exact same thing, but just as a different picture. So that's what we're going to see next, is a box and whisker plot. So a box and whisker plot looks like this. So you'll have a whisker, and that will be, so you'll have your whisker down to your minimum value. So on this data set, what would be our minimum value roughly? 55. Does everybody see? So in this data set, there's a min of 55 roughly. All right, now the top of your whisker, your top whisker will go to your maximum. So roughly, roughly, right? These are rough. Okay, so then right here, what our box contains in our box and whisker plot are your quartiles. So here's quartile 1, which is the median of the lower half of the data set, correct? So our Q1 would be roughly 62-ish. What is the actual median, roughly? 73-ish, okay? And then what would be our quartile 3, the median of the upper half? 84-ish? Does everybody see what a box and whisker plot is? It's just showing min, max, and your quartiles. So if I asked you what's the interquartile range, you would do 84 minus 62. If I asked you what the range is, you would do 87 minus 55, right? Okay, so a box and whisker plot is just another way to list out a data set. Let's go, now look how nice this is. If we can have a box and whisker plot, we already know our median. And so we don't have to do any math by hand. Okay. Let's do number 8. It says, create a box and whisker plot for this data set. So I'm going to now show you how to do it in your calculator. We don't want you to have to go through and do it by hand. You could do it by hand, couldn't you? Couldn't you put it in order from least to greatest? Find the median of the lower half. Yes, okay. But we're just going to do it by calculator. So everybody pull up your calculator. Follow me through this from start to end. So everybody stick with me so that we only can explain this one time. So everybody hit the second stat plot. So second y equals. Now you should see this screen. Second y equals stat plot. Now what you're going to do is go into number 1, hit enter. Now you're going to go down. Right now yours says off. You're going to highlight on and hit enter. You're scrolling down. Now it says, well, what type of plot do you want? So we're going to pick. Notice there's 2 box and whisker plots. Look, this box and whisker plots, what it's doing is it's throwing out the outliers. It's putting them in there so you can still see them, but it's throwing them out. Does that make sense? And then right here is my box and whisker plot with my outliers. We would only ever do this if it asks us to take out the outliers. But otherwise, we're going to just put the outliers in. So we're going to click on this one and hit enter. So you should highlight it, go over it and highlight it and hit enter. Now you should just see list 1. Do you guys all see list 1? Okay, now we're going to get out of here. So you can hit second quit. So second mode, second quit. So now hit the stat key. We need to give it some values to make our box and whisker plot. Hit stat. This is statistics. That would make sense. So stat and then into edit. Now in list 1, notice I have values. I need to go up to list 1 and I'm going to hit clear. Not delete. If you delete list 1, you've got to reset your calculator because I don't know how to get it back. So I've cleared out my list. So ready, set, go. Start typing in values. This is number 8. Notice we don't have to worry about putting them in order. We're just typing them in. Your calculator will do that for you. All right, we've got them typed in. Okay, so we're trying to make a box and whisker plot. So we hit stat edit. And now we've got in list 1 our values. So now if you hit right now, if you hit graph, look and see if you can see your box and whisker plot. Now if you can't, here's a couple things that could be wrong. Your window. If it's blocked off, go to your window and change it. So our lowest value in our box and our lowest value in our data set was 2, so I made my X min 1. To me it looked like the highest value was 32, so I made it 40, X max, 40. Then X scale will leave as 1. Y min and max do not matter. So you can just leave them. It doesn't matter what they are. So now if you hit graph, great. If you're seeing extra stuff in graph, like a square root function or some weird thing, it's because you have stuff in your y equals. So you can go into y equals and clear that out. Just hit graph. Now I need to know these values. So what you hit now is just trace. Simply just hit trace. Look, just right on trace. And now you can use your arrows to jump. So now, do you see how it tells you? Our maximum is 32. Our quartile 3, the median of the upper half is 15. Our median is 10.5. Our quartile 1 is 6, and our min was 2. Now, you don't have to draw it to scale. I'm not worried about you drawing it to scale. I mean, obviously draw it like a little bit to scale, but what I mean is I don't need you to go make a number line and make it perfect. So this would suffice. Let me show you on the test what would suffice. You could literally go, okay, so I have a whisker and then a box. And this one was a little bit longer, yeah? Then you would go like this and label it. So you'd say 2, 6, 10.5, 15, and 32. I don't need you to draw it on a number line making it perfect. Good enough? Okay, awesome. So now if I asked you what's the interquartile range, you would do 15 minus 6, wouldn't you? Okay, cool. I think you get the picture with a box and whisker plot. So if I ever gave you a data set and said find the median, you could just type it into your calculator and you could use this middle line here. Now, one more thing to note, some of you might really like this. I'm going to show you. I usually don't ever show this, but this is cool. If you wanted to get your data set ordered for you, so you don't have to go through and order it from least to greatest, your calculator can do that. What you'll do is hit Stat. Now, normally, so Stat, we go into Edit normally. So now we're going to go to Sort A. So I go Edit, Sort A. Then I'm going to tell it I want it to do Sort List 1. So I hit Second 1, because that's List 1 above, notice. And then I hit Enter, and it says Done. So now if you go Stat, Edit, it's all in order for you. Now, how would that be helpful? Because now to find your median, well, your median is your middle, correct? It's already in order for you. But why would we do that when we could just do our box and whisker plot and do median? Does that, you know what I mean? I mean, you can if you want. Okay. Okay. So what I'm going to have you do for a second before we move on to the last part of 8-1 is I want you to work on the front page for a second. Ready, set, go. So everybody, we have to know what a percentile is. This is actually really important, and it's used all the time in the real world. I mean, it definitely puts everything into context. Don't start reading that. I'm going to explain it, and then I'll read it because it makes more sense if I explain first. I'm just going to give you an example right away. So a percentile is a ranking, basically. It gives you a ranking versus all the other students in the school or in the world, whatever you're comparing. So for example, if you are, let's say I put all of your grade point averages on the board here, and I listed them from worst to best. If I said, congratulations, you're in the 90th percentile, what that means is 90% of you scored below her. Have a lower GPA than her. So that's really good, right? 90 percentile. So, and that can be at her score or below. At or below. Does that make sense, everybody? So there might be a few people at that score, but also below. Now, so here's why that puts it into context. Let's say that you on the last test got a 30%. And this isn't true, but let's pretend. Like you got a 30% and you went home and cried yourself to sleep. Well, let's say then you came the next day and I said, congratulations, you got a 30% on the last test, but you scored in the 95th percentile. Should you have cried yourself to sleep? No, because 95% of students scored below you. So it puts scores into context. Now let's put it in the other way. Should you feel good about a 90% on the test if you scored in the 30th percentile? Yes. No.
Actually, probably.
No, because you only scored higher than 30% of people. Does that make sense, everybody? Okay, so let's look at how we would find that. Here are some test scores it says for a Spanish class. We'll pretend like it's a math class. So here are some scores. This is really important, everybody. You need to do a percentile correctly, it's a ranking. You need them ranked from worst to best score. So we have a 41, and then the highest score is 100. You guys see what I'm saying? Now, to find a percentile, it says, what is the score at the 65th percentile? Now, it has nothing to do with these numbers. It has to do with, well, how many scores do we have here? So, there are 20 total scores. Do you agree? So, if that's true, it says what score is at the 65th percentile? You're going to take 20, and you're going to times it by, you're going to find 65% of 20 scores. So you would take 20 and times it by 0.65 and you get 13. So then you're going to go to the worst score and count in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 82% is at the 65th percentile. Do you guys see how it had nothing to do with the numbers inside? It has to do with total, which makes sense because it's a percent. So you would say, okay, if you got an 82, 65% of students scored at you or below you. Does that make sense? Okay, so let's go the other way. If I asked you, given these scores, if you got a 97, what percentile did you score in? So how would we do it? Isn't that the 17th best score out of 20? So you would take 17 divided by 20. 0.85. So that would be the 85th percentile. 85% students scored at or below you. So now looking at this one last one, if I said to you, what score is 98? Do you see how there's two of them? Yeah. You would go to the furthest best because it's at you or below you. Does that make sense? So you'd go to the furthest best, the best, so that'd be 19 out of 20, which is 95th percentile. Now I always have people say, well, how is that 95th percentile when there's only one score above? Because it's a percent, not numbers, like not a one. You're not going in ones. Does that kind of make sense? Okay, do we get how percentile works? Now I'm going to tell you guys, we looked this up. This is an interesting fact, okay? So it says right here, a percentile is an everyday it's used in every day, but there is no universal definition for it. The most common definition of percentile is a number where a certain percentage of scores fall below that percentile. So it says you might know that you scored 67 out of 90 on a test, but that figure has no real meaning unless you know what percentile you fall into. If you know that your score is in the 90th percentile, that means your score is better than 90% of the people who took the test. Now, fun fact for you, so when you go to, like, if you're wanting to go to an Ivy League school, there's usually a test you have to pass. Like, usually they have it be an SAT. Now, if you're going to go to law school, you have to pass the LSAT. So a lot of times, like, to get into Harvard Law, we looked it up, you have to score within the 80th percentile on the LSAT exam. Or you can't even apply. They won't even let you apply. That's just the first check mark. I scored within the 80th percentile on the LSAT compared to everybody else that takes it. So there was a girl last hour that said her brother-in-law scored on the 89th percentile on his LSAT. So he can apply to Harvard, but if you score in the 60th percentile, you can't even apply. Does that make sense? Then there's obviously other factors after you meet the criteria. Now, all of you can see on your ACT what percentile you fall. Because I know there's probably some of you out there that probably feel pretty sad that you got a 26. But when you find out you're in the 90th percentile, does that make you feel as bad? No, you should feel good. Does that kind of make sense? You shouldn't feel bad if you got a 26. That's a great score. I was just giving you an example. Does that make sense, though, everybody? Okay. You can actually compare it on the ACT to Utah and the United States. So how would I do this? This is just testing your abilities, and I'm going to let you work for quite a while. If I gave you these scores and said, what is the value at the 55th percentile, what would you do? You would multiply 20, there's 20 scores here, by 0.55, and then you would count in that many values, right? Okay. So I want you to do 8-1 for a while till I stop you to go on to 8-2, which remember we're not fretting because next time is going to be also a homework day, right? Okay, work on 8-1. Go do some percentile ones. So in 8-1, what we did was we took data sets and we were really looking at the center of the data, right? Mean, median, mode, and whatnot. Now we're going to be dealing with standard deviation, which is more spread. We're going to now focus in on spread, how our data is spread out. So keep in mind we have already seen spread. Isn't range a way to describe spread? We're ranging over this amount. So now this is just another way to look at spread. So standard deviation, let's read what it is. Standard deviation is a measure of how far the numbers in a data set deviate away from the mean. So now instead of the word mean, I'm going to put average and reread it, just so it puts it into context for you. So once again, let's read this. Standard deviation is the measure of how far the numbers in a data set deviate away from the average of the data set. Now think about it. Average average is a measure of central tendency, correct? So we're going to be in the middle of a data set. And then all of the data after that will then be either close to that or far away from that. It'll be spread out a certain way, essentially. So, couple things to note. You're going to need to know this. Sigma is a Greek capital letter. That means find the standard deviation. You're going to need to know that. Because I might, on a test, they literally might just go like this. Find sigma. You have to know that that means find the standard deviation, which we're going to learn how to do it with our calculator in just a second. And then variance is sigma squared. There's not a way with your calculator to find variance. All you have to do is take your standard deviation, whatever it is, and square it. And then x bar is the same thing as mean. That's just a symbol of saying find the mean or find the average. So, I'm going to first show you, and then we'll put it into context of meaning next. I'm going to show you how to find these things with your calculator. So once again, pull up your calculator. We're going to do number 2 on 8-2 together. So go to Stat, Edit, and in list 1 you need to type in your values. So once again, look, I scroll up to list 1, hit clear, scroll down, and now I'm going to go and type in those values at number 2. Okay, once you've got them typed in, what you're going to do is hit the stat key again, stat. Then we're going to go over to calculate. Stat, calculate. Then we're going to do the one variable statistics since we're only dealing with one list. Then hit enter, and it's going to pull up a lot of information. This is going to be really useful for you because now look what it finds for us, the mean. Do you guys see how in 8-1 we could now go back and just do it by calculator instead of having to add them all up and divide? Okay, so our mean is 30.3. Ignore this says the sum of your x's. Well, we don't care about the sum. And then it says sum squared, cool. Then S of x, that is a standard deviation, but we're not going to use S of x. We're going to use sigma of x. So these are just two different standard deviations. It just depends on the book or the statistician on which one they choose to use. But notice they're pretty close. We're always going to use sigma. So you can write that down. Now look how cool this is. If you scroll down, it gives you even more information. It gives you your min, quartile 1, median, quartile 3, and your max. So you wouldn't even have to actually box and whisker plot it. Couldn't you just get that information and draw a rough box and whisker plot? As long as you know how a box and whisker plot looks. Okay, so awesome. This is what you're going to do. So you would just say on number 2, you'd go, okay, so my mean, x bar, was 30.3. Sigma is your standard deviation, which was 3.2. So now we've got to hurry and find our variance. You'll do sigma squared. So you'll take 3.2 in your calculator, and then you'll do 3.2 squared, and you get about 10.2. We actually don't ever use variance in this level. Like, we're just going to be using standard deviation, not variance in this level. But they will ask you to calculate it, but we're only going to use the mean and the standard deviation. Okay, now let's put this into meaning so that we can look at and evaluate the spread of a data set. Okay, so everybody right here, it says, let's say that we have 50 as our mean, and we're going to let our standard deviation be 10. Well, if that's the case, I've set up this like picturesque type thing here. This is just a picture to give you a visual aid here. So do you guys see how I'm adding one standard deviation? That would put me at 60. That's one standard deviation above. Well, one standard deviation below would be subtracting 10, and that would put me at 40. So any value, you guys, that falls between 40 and 60 falls within one standard deviation from the mean. So it's close to the mean. Does that make sense? Now, 2 standard deviations above would be up to 70, obviously. 3 standard deviations above 80, and so on, so on, and so on and so forth. So I'm going to ask you, within how many standard deviations does 42 fall? So where's 42? Right here? So this would be 1 standard deviation. Where does 19 fall? How many standard deviations? 4 standard deviations away from the mean. So it's quite far out, correct? Okay, where would 63 fall? 2 standard deviations. 80? 3 and deviations. Okay, now fun fact for you. Any value outside of 2 standard deviations is by definition an outlier. That's something you need to know. From here on out, if I say to you, given this data set, what's the outlier? You're not going to just look with your eyeballs. There's some that are obvious, but there are also some that are not obvious. There's always people that don't do this calculation. They don't see how it's spread out, and then they say that something is not an outlier that really is. Relatively speaking, they're like, well, they look all pretty close to me. Well, anything that is not within 2 standard deviations is considered mathematically an outlier. So now let's look at this next example here. So it says, within how many standard deviations does all of the data fall? So it says the mean length of Beethoven's 9 symphonies is 37 minutes. So I'm going to put a box around that. That's our mean. And then it says the standard deviation is 12 minutes. So let's draw ourselves a visual aid here. So add 12 minutes, what would we be at? Add 12 minutes. And then I'm just going to go 1, 2 standard deviations on both. And then if I need to go out further, I can. So 1 standard deviation below, subtract 12. Subtract 12. So there's 2 standard deviations. Okay, so here we go. This 27 falls in this first standard deviation, doesn't it? 30 falls within the first standard deviation. 47 falls in the first standard deviation. 35 falls in the first standard deviation. 30 falls within the first standard deviation. 40 falls in the first standard deviation. You guys see how all the data is really close together? That's a good thing, guys. The closer the data, the lower the standard deviation, the lower the spread, the more reliable your results. Anyways, 35 is within 1 standard deviation, and then 22 is actually 2 standard deviations. 65, it's out here, isn't it? In the 3rd standard deviation. So that would be considered an outlier, wouldn't it? And our answer is, it says, within how many standard deviations does all of the data fall? It took 3 standard deviations to entrap all the data, didn't it? You don't add the top to the bottom, you don't do weird stuff. It took 3 standard deviations to trap all the data, period. That's all you have to do. Okay, so this really is important because, once again, if you were a statistician, you would want to look at the spread of your data so you can see if your statistics are reliable or not. Okay, so let me just state this, okay? A low standard deviation means that the data is very closely related to the average, thus very reliable. A high standard deviation means that there is a large variance between the data and the statistical average, thus not as reliable. So just keep that in mind. It helps you know if a data set is reliable or not. And then it also helps you know if something's officially an outlier. Okay, so notice this is my last example. So one last example here. It says, within how many standard deviations does all of the data fall? Notice we were not given the standard deviation and we were not given the mean. But we can calculate it. Our calculator calculates it for us. So remember, you go to Stat, Edit, in List 1, type this in. I want you to do it. Real quick. I need to do mean, and I need my sigma. So then you go Stat, calculate 1 variable statistics. 6.6 is our average of this. 3.2. Okay, now I'm not going to draw myself a visual aid for this one. I'm just going to answer it. Now think about it. If it says, how many standard deviations does it take to entrap all the data? I'm going to need to go to my lowest value and my highest value only, aren't I? So if I start with 6.6, how many standard deviations below is 2? Within 2 standard deviations. Now, how many is 12 above? Within how many standard deviations? 2 standard deviations. So how many standard deviations? 2. It all fell within 2 standard deviations. Therefore, there was no outlier. Okay, awesome. So start working on 8-2 now. So you have some practice with that for next time.